Hello everybody and welcome. Today we'll be doing the next part of our simple tutorial series and we'll be focusing on stairs. Let's just say yes of that. Now the model we'll be using to create our stairs is this one over here. Just a nice simple little staircase, and you can find that to download in the description below. I'm going to start off with just setting up the project properties and grid lines. You're welcome to skip it. Project properties, edit. Let's see, our project number is PL-SS-013. The project name is Recovery Project. Our client in this case is TID. The description of this would be wood chip tank steel stair, and site address is our sub plant where on the gold mine this is located. So thickener and screening. Now, as for our levels and grid layout, we'll be using a height of 0 to start from, going up 1385, using the names of plus 1704, comma 210 and plus 1705, comma 595. For our x, we are going to use a distance of 1775. Now, unfortunately, we only have two grid lines as a reference, and that's A and 1. We are going to use our own naming for this one over here. Make it 1A, or 1A and 1. As for our y, we'll be using a 0 again. We're going to bring it out 1862. And for our naming, we'll be using A and CL for the center of the stairs. Modify that. Now, as I said, we've only got A1 over here, but our stairs are right up here. We still do need to give these two as a reference point so that they know from where to lay out the stairs. I'm also going to change these to about 750 should work instead of 2 meters, as I don't want my grid lines sticking that far out. Good for a large building, but for something small like this, works much better if it's tight. And yeah, once that's done, I'm going to fit pod, get everything nice and snug, and then from here I'm going to create a section view of our center line. If you don't want to use the view by 2 points, you can of course always just select the grid lines and then create view of grids to get your center line that way. Besides the center line, we are going to put in a beam, and this beam will be relatively from somewhere over here to that side. Same with this one. I'm just going to put a line through. Now for the bottom one, I don't really care that much up to where it goes. For this one over here, I'm going to move that to the center, and then I'm going to move it 375 in, and that should look roughly the same as the drawing we are working from. Next, I'm going to open this up. I might as well open up both of them, and I'm going to change the profile to the existing material grade, nice color like 8, to show that it is completely different from the other ones I used. Now, the exact color you use here does not really matter. I would suggest pick a color, set it aside all of your existing stuff, so that if you're using existing or components, that you know from a glance what they are. After that, I'm going to change the profile sizes. For the bottom one, we're using a 406 by 140 by 46. Modify that. For the one here at the front, we are using a 203 by 133 by 25. Go ahead and set that. I'm also going to move over to the center line, and we're going to move this on up over there. Now we've got our two existing members set in as references to work from. The next thing we would like to do is head on over to Edit, Construction Lines, and put some reference lines in to work with, as we like to get our SOP points, our setting up points for our stairs. Now, for the top one over here, we have to lift it by the 40 thick grating that we are using. Now, at the bottom, we probably have to do something similar, but since we don't, since our bottom tread isn't exactly 200 from the floor like the other ones are, we aren't going to do anything there at the moment. What we are going to do is get our SOPs the other direction, which means a 100 and 315 in the Y, well, X, pardon my mistake, and 220 in the X. And this should give us roughly our setting out points. From here, I am going to put in the stair, and I'll probably have to fix the SOP afterwards. For the stair, I'm simply typing in stair, and I'm going to use this stair S71. It should have everything I need. Now, stairs are put in from start to the bottom. See, there's 1 and 2 at the top. Remember to set your snaps right there, and once you're done, little mouse to confirm. So that. Now, first thing I'm going to do is head on over here and just make sure that my profile size is the same as theirs. Then I'm going to look at my step if needed. Let's head on back and change this meter to about 315, which is, of course, exactly where it should be. But note, as soon as we bring in our grating, it's no longer long enough. That does not matter though, as we will be lengthening it along with the connection. Now, as for the bottom, we don't really require it to stick out any, so we're going to make that 0. Next, I'm going to use Shifted 2 to get a nice see-through picture, and I'm going to change my distance between stairs to 200. Modify that. Then I'm going to quickly take a measurement just to make sure that it is 200, which it isn't. Now the reason for this can be quite easy to figure out. It just means that I've divided it equally, and the distance it's currently cannot be divided into 200 equally. So what I'm going to do is take the top line and I'm going to copy it linear down, minus 200, and I'm going to have 10 of these. Doesn't really matter, I'm not going to use the extras at the bottom, but it's a lot faster than trying to figure out how many there are. After that, I'm going to move my SFP point slightly up to about here. It's still in its original line, so it hasn't really shifted or rising or going any, but because it's now an equal divided amongst 200, I'm getting the correct amount for my stairs. Just confirm that with a dimension. It's 200 and 200. Good. Now, you have basically two options. You can either settle for whatever it works out there. You can go and get it to be an exact amount of stairs, and it will divide the stairs up amongst that amount instead of going for a distance, or you can adjust your SFPs to fall within the desired rise, like we just did now. From here, I don't think I need to change anything else at the moment. Now, I would have done another 40 over here had we done the floor at the bottom, but we don't worry about this at the moment. Next, we are going to look, yes, we do have a bit of a overhang, so that should be fine over there. I think that's it for the step. Now, do note that this will have to increase slightly. That should be about 70, which is the width of the stair. If we head on over to our assemblies, you'll find that they are basically aligned according to the stringer and a little bit at the top. And the reason for this is because they see this as the main member. Now, you can change your main member by selecting, right-click, going to assembly and setting your new main member. And this will of course change your assembly. Now that this is the main member, it's horizontally aligned according to this member here. And both cases will handle differently within the drawings. A little bit more on that later once we get to the drawings. For now, what I'd like to do is the connections. So we are going to use number 27, a stiffened end plate. Let's change this back to normal. And now I'm going to put both in and then start editing. Now, luckily for us, they do give us this connection and it's fairly straightforward. We are using a full-size plate, so we will be putting in 6 both at the top and at the bottom, and this will give us just enough space to do a weld. After that, we are going to make sure that everything is a 10mm plate, and then we'll head on over to bolts. Now, from the top of steel, our first bolt is 70 down. We're going to have 2 rows, and they are going to be 70 apart. We do not need to add anything to the top and bottom over here, as we've already added 6 mils over here. For cross centers, we don't really have a cross center, as we only have 1 bolt situated right in the center. Now, unfortunately, the bolt isn't right in the center, but it's a little bit off center. So let's get a nice top view, open this up, and have a look at our settings. One side will be 45, the other side will be 30, as they show in the connection detail. But our connection cannot be centered. It's going to move about 7.5. Currently it's right in the middle. We want it on the back mark at 45, so we just take the half minus the 45, and that gives us the 7.5. If we take a measurement from the bolts to the sides, we'll see that our Y is 30 and 45. Now be aware that although it works great on this side it is the wrong way around. Let's just move this out, I think another 5. Okay, so we'll need to swap it over, and we do that by changing the 7.5 to minus 7.5 and then just swapping these two values around. There we go, now it's on the other side. Next we would like to do the bottom over there, and for this I'm just going to type in stair again. Now for this connection here we are going to use stair detail 1038, and we're going to do it from this side. We are going to take an area selection for our members, and that's so that we can select both of them at the same time, and I'm just going to put them right over there at the SMP point. I'm not really too concerned about where I put it in, as I'll be moving it afterwards. Once that's done, we are going to open up this connection, and we are going to make sure that we are using 10mm plates as requested on the connection detail number 2. We're also going to head on over to bolts, and we're going to say we would like 2 bolts at 70 distance apart. Now with the exact positioning, we can just take both of these with an area selection, do an area selection to get both of these nodes, and what we would like is basically the center of these 2 bolts right up there. As you can see, didn't really work out, not that we expected it would. We're going to get the center of these 2 and then just move this forward again, and that gives us roughly the correct location. Now it probably is still off, as you can see, so for the next part we are going to take these and explode them. Afterwards take the bolts and just move them forward a little bit. There we go. Now the reason I'm doing this very roughly is we've got no set distance from here to our SOP. We take a measurement that is currently 142, and that doesn't really matter. For this specific one, we do want it to cut off some, and we want enough space between the bolt and the side, which we currently do have. Next, let's head on back over here and get a top view again. Make this transparent with a shift 2, and we're going to take these 2 and then just shift them up by that's 40, so that's 35, so 10 to get us at our 45 back mark. And we are going to do the exact same thing here at the bottom. We are simply going to take them, measure them 40, and shift them the next 5 so that we've got a 45. And that's a fairly rough way of doing it, but it wouldn't have worked either way. As you can see, our measurement over here is 35, and one side it does 35 from the back, the other side it does 35 from the front. So exploding it and doing that part manually is usually the best option. After this, we are going to take these bolts and we're going to say bolt parts and bolt them to both our plate as well as our existing beam. And that is the main reason we put this beam in, is so that we can get the correct length on the bolts as well as help us when putting in the connection. It should be about that. The next thing, of course, I'd like to change is I'd like to select my stairs and just change their assembly mark to be T for T for tread. It doesn't necessarily have to be T and tread, but the name has to be descriptive and the assembly mark fairly descriptive as well of what you want it to be. Stair stringer. Now, of course, you can do this right here in the component. You'll have to do that M, that is your mark, and then of course down here, that is your mark for your step. Once that's done, we are going to put in our hand railing, and I'm not going to do the hand railing catalog just yet. I just wanted to give me the hold positions. So I'm going to type in railing to get a list of all the options. Railing 1024 should be good enough. And we're going to go here and load up our top sloping. Now, the main difference between top sloping and top horizontal is the size of the plate and the distance of the holes, more specifically. So the distance between these two holes on sloping is 130, whereas if you're doing it on the top of a floor, it's only 100. Do note that this is specific to the port-out hand railing that we primarily use in South Africa. Yours might be different, or your company might have a custom set of hand railing, as most of the mines does. And in that case, you'll have to adapt yours to fit their needs. The top and bottom should be fine, with the only real difference I'm going to make being shifting these over to be according to the back mark as well. That will be minus. Do note that on some of the older versions, even though you've got it in the correct position according to this, the bolt might still be incorrect. So you will have to adjust for that. This is plus. Good. And as you can see, do take a measurement even after you've done the connection. Although I put it in here, I know it's correct. Once I do it this side, just check again. No, it's correct. As Tekla likes to mess you around in the most unexpected of times. Okay. From here, I'm going to open up the properties. I'm just going to load up the standard. Give me the standard sizes there. I'm going to also check my CL to make sure that it's still side and not moved, because I'm now going to create GAs. The GA is a direct reflection of what is in your model. So if you make a GA, you remove a part, then the GA is going to change. First, let's create a number modified, just adding numbers to all the parts. After that, we are going to say create drawings, and we are going to create GA drawings. For now, I would only like CL as well as that, and let's take the floor as well. We only really need one of them. Okay, this will give us our 3 views. From here, I'm going to say, let's make this 15. Still a lot of space. I'm also going to take my drawing, double click to get the properties, go into layout, and I'm going to change this to, let's see, this is currently A1, so I'm going to bring it down to A2. Bit of a smaller drawing, but with the minute size of our current drawing, that is not a problem, as we won't have a problem with space. For the plan, double click on the gray backline. As you can see, it does not show the bottom of the stairs. We would like to see everything. So we're going to change our depth here. Let's see, we'd like to see all the way up. So let's just make this 5 meters and 5 meters. Note that you can control this to get it to be whatever you need it to be. And in that case, if I only wanted to see up to here, I can just take a measurement, add that amount to my down in this case, as I'm using the top, and it will only show that much. Once that's done, I'm going to just bring this down right about there, bring this in, and that's because I don't want my lines sticking out that far. Now, when it comes to the 3D over here, we have a little problem with our grid line right inside the steel. We're going to open this up and just say we would like to swap the node from the top down to the bottom. The correct one changed. If the incorrect one changed, you can always just change it over here. As you'll find with most of this stuff, I'm a large believer in try something. If it doesn't work, try the next thing. It doesn't work, try the next thing. And sometimes it takes a little bit longer, but mostly it's faster than trying to figure out which one it is without doing anything. Better to be active and wrong, all that. Now, for the next thing, we are going to get a nice colored in look. So we're going to head on over to parts. Next, we're going to go over to fill. Here we would like our solid, and we would like this special color. Now, the difference between the special colors and the rest is that the special is more like a gray haze than anything else. Take that. So it'll still give us our nice bright lines, but it'll give us a light gray haze when printing this. And this adds a lot of depth and makes it easier to see, especially for the guys that aren't detailers, that aren't engineers, that don't necessarily work with drawings that often, and they can more easily see the depth and what the part is. Be careful of this one over here. Although it looks exactly the same, it is a non-printing layer. No point in doing the extra effort to create a nice beautiful look and then have it not print. Move this over here. I'm going to take this and move it down there. that a little bit over here. Now we've got a little bit of open space here. It doesn't really matter too much. We can always just move the stuff around again until you find a nice look and feel to your drawing. Let's put that down there. Of course, we can just go and scale it down some more or scale it up some more, but generally that is not required, especially with the size of this stuff. And of course, you can see I've got my reference grid lines in my 3D, which also really isn't even needed on the 3D at least. You only really need to see the reference grid line on the top view to show where we're coming from. The next thing I'd like to do is I'd like to get rid of the solid color on my existing items. The reason for that, quite simple, and that is I want a visual distinction between the new steel and stuff that should already be there. And we are going to do that by making this a dotted line and removing the fill. So make this a nice fine dot. There we go. And now you can easily see it is there, well, sort of there and sort of not. So it's easy to tell it shouldn't be. After that's done, we're going to put some marks down and add marks. I'm going to open up these, take these bottom ones as well, and I'm going to tell them to be inside, right over there. And that just looks neat to me. Mostly just preference. You can leave them outside where they were. Let's add these two as well. Remember, this one is at the top one, and this one will be a part of that one over there. Since I don't really find that all that appealing, I'm just going to add mark to the top one, which doesn't really have a mark because it's not the main part. What will happen then is Tekel will open up this properties, and we are going to go and load our standard and modify. Now, the standard here is our mark, name plus section size, and we can give that. Personally, it doesn't really matter what you give as long as you give the assembly position. That's the most important one. The rest of it can be nice, but it all depends on space. If you've got the space for it, yes. Giving the extras might be nice. If you don't have the space for it, at least the assembly mark. The rest is not as important. Now, from here, I'm also going to add a B1. I can add that as well. Maybe add the B1 here. And the reason I'm adding the B1, but I won't be adding the bottom B2, is because we've got absolutely nothing to do with the bottom. It is there, it exists on site. They're going to have to drill some new holes to fit for these bolts, and that's about it. But for the top, they are going to have to weld in these brackets for our top connection. And since they'll be doing that, we are going to create a drawing of B1 to show them where and how to weld those stuff in. When it comes to dimensions, firstly, I'm just going to open up the dimension. I'm going to say here, I do not want grouping because, well, the grouping is fairly horrible. If I want a dimension denoting that I don't want it to show up like this, I would rather have it look like that. Let's go to marks, and I'd like it to be visible. So at somewhere we are going to have to add a singular dimension, get this visible, and even though it's grayed out, because it's now visible, we can modify and show it. Now, don't get me wrong, besides the fact that the stuff is hidden, which is horrible, idiotic, as a base setting, this one here does have, well, this one here does have its purpose. And sometimes it can be nice, it can work well if you're using it the way it should be used. Just apply this. But it can also be as irritating as anything if you don't use it on a majority of stuff. Of course, definitely not that bad compared to automatically having the mark hidden. Let's get the heights over here. Then, now normally I'd also put in the 40 for the grating, but we did not do the grating, so that is not necessary. We're also not going to do any of the tread heights. Again, that will be in the drawing itself, or in the assembly drawing itself. It doesn't need to be shown here. And I think that should be about it. Let's just add another one here for clarity, and that should be everything, for the GA at least. Now, normally I would go and change the drawing name, like I'm about to do on my assembly drawings. But as we only have one GA, that is not needed. Let's run our auto drawings. You'll find it as a component over there. And I'm going to run my landscape only setting. Once that's done, let's open this up and move this to the side. As you can see, we've got 3 assembly drawings, and then we've got the parts inside. We do not have this thread, so we'll need to select the thread separately and create a drawing of it. It is not an assembly drawing, it is a simple part, although it is the main part. From here, I'm going to open up the assembly properties on this beam. I think I'm going to go for intermediate, and I'm going to make this an A4, A3, 2. Keep this the same as the GA. I'm going to rename this as beam. Select these two, rename them as stays trimmer. And this part is mainly for the benefit of my lists and the client. And this one will be a different setting, properties, as it's a single part, but we are going to use the same paper size. So let's head on down, find a profile that is A2, call this thread, and these I'm going to leave as they are. Modify. Okay. Let's start off with the beam. Upon opening this up, you'll see that everything is this nice grey color that we've got, or that we had to put into our GA, but we don't want this specific item to be that, so we're going to check that off. Next, we don't want any dimensions referencing from a specific point, nor do we want the beam's actual size or part mark. Again, it's existing, we don't really care about it. What we want to do is give a dimension that tells us where our items are. Just combine these two in relation to each other and in relation to the beam. Existing beam's position if we've got it. Now, we don't necessarily have that. We are going to say it has to be 70 from top. It's going to have stiffness at the back, B1, and it's going to have a plate at front of B2. Nice there. B1 at the front with the holes, and we'd also like to just arrange this a little bit. Put in a note, go over to text with a leader, and just put that in, move that out, and say to be site place, and of course you can add whatever other notes you need to this, something like specific corrosion protection, their procedure, what they need to do, according to what specification they need to do it, if the welder needs to have a certain certified status, or pictures need to be taken and sent to the engineer, all that type of stuff you can add to this note. Just apply that. As different areas and different types of projects have different rules when it comes to welding on site. Now, normally with the mines, it's a big taboo. They don't want welding on site, but with commercial projects, store buildings, malls, that type of stuff, not as big an issue. The corrosion protection does not have to be as strong or as potent. Now, with these stairs, the ST1 and ST2, you'll see that the main part means that this is angled like that and doesn't really make for a good drawing, whereas this, although it's got horrible dimensions, it looks a lot better. So, first thing we are going to do is we're going to take ST001 or ST1 and we are going to rotate it. By how much? Well, we'll have to go and measure. Let's go over to our grid line CL, go on to over to edit and get an angle dimension. From here, we'll just need a straight line, angled line, that's 40.305. And we can head on back to the drawing with that information. So, our drawing needs to rotate by 40.305. Either plus, minus, you can pick one, doesn't work, just remove it, add it, and rotate it twice in the other direction. Now, when it comes to this one over there, that one over here, I do believe these are actually quite good as is. Let's just make this a little bit smaller, a little more compact, and of course get rid of this one that goes into the middle of nowhere, and just re-add it, say like that. And that's a fairly good drawing. For the other views, top view can again stay as is, and we are simply using it to give us our 45 over there. I'm going to remove this as it's not quite clear or not clear enough. Now, as for the rest of the dimensioning, I'm just going to delete all of it and I'm going to do it myself. You can, of course, instead of deleting everything, just go and mess around with it, edit it until it looks nice, but I'm not going to do that at the moment. Get rid of that. Now, we are going to start off by doing a overall dimension from top to bottom. We're also going to add this little bit over here. Let's add a little bit in. I'm going to add the 10 at the bottom. Let's combine it with that one. Then we are going to add a dimension that basically tells us the height of our holes. This over here, and use the rest with the add command. Then we are going to do the exact same thing for the horizontal. Basically just add a dimension from the top of our sloping member to the bottom of our sloping member. Add that over there. The 10 on the side. You can add an overall. Not really needed. The most important dimension here is firstly this one over here. We can use to angle out the stair. And then of course the positioning of the bolts. Now I'm only putting in a dimension to the front of the bolt, and that is so that all of these are nice and the same. What we are going to do is add another dimension over here to tell us the distance between the first and the second bolt, and head on over to tags, put this in as typical right over there. So we've got our initial bolt position and we're telling us 115 typical. What I would like to do though is I'd like to take these and go on over here and show an excellent example of where this works well without the typical. Something like a stair, this does look nice and can work. Cancel that, won't apply any of those settings. Next, we would like to do these holes on top. Now, I don't really trust my start and end point, so I'm going to take a point that I know the height of as my first and last point determines the angle. Here I'm going to take the last point and then end up again with the top there. At least then I know these bolts are always nicely aligned because of the first and last point bit. If you don't want to use this, you could always use something like perpendicular or parallel, and in the case of something like those, you would pick your 2 points just to get a line, and then from there it doesn't really matter how high or low the points are, they will be aligned to the first line you made. And that'll be it for this stair. Yes, we've got that over there, we've got this one over here, we've got a top for the 45 back mark. We don't have any other holes or anything else to do. That should be it. Now, for the next drawing, I'm not going to go through all of that effort again. The main reason for that is we already have a drawing that is 90% the same. It's the exact same item. It's just the opposite hand. So, we are going to take all of our parts, we're going to add marks to them, just to show that they are the same set of parts. And then we are going to take text, put some text down, which is going to say to be same now wait, to be opposite hand, as it is a mirror image of stair stringer ST1, to be opposite hand of stair stringer ST1. And this way they will know they use the exact same measurements, dimension, everything else. It's just the other way around. And I'm going to put a box around this, make this nice and big. put it right there in the middle with no dimensions. And this is a good way of saving time when parts are technically the same or similar enough to be able to do this. And it's something that we did quite a lot on the drawing board and on AutoCAD or other less productive programs. Well, at least less productive for this particular application. They've got their own wonderful set of applications. And that should be it for the drawings. After this is done, I am going to, of course, do the stairs. And we will need to, it does say landscape, but obviously Tekla does not understand what landscape means. So let's just swap these two values around. Modify that. Does that. Wonderful, that's now landscape. Now for the stair itself, or the tread, for the tread itself, we are going to be using an template from AutoCAD, this one over here, that we are going to put in. Just apply that and stick it in because, well, it looks nice. Let's double up on this, make it nice and big, take a good amount of the drawing. I'm going to get rid of this line by changing its color to this little one over here that we mentioned was a non-printing layer. So even though it's still there, like these blocks, it won't print, so it doesn't matter. Now, this is incorrect. So, what we will do next is we're going to open up that AutoCAD file and quickly fix it up to be correct according to our current stair. 40, that's 30, that's 115, and that's 245. And this is a good representation of what a grating stair looks like. There again, and we're just going to modify this and make sure we're using the latest of these. It's always a good idea to get a CAD file from your supplier or whoever you're getting your treads from, or simply draw one up. It just has to look fairly good with all the right dimensioning, and that's a good way to have a nice picture to work with. Once that's done, I'm just going to save this and have a quick run through all my part drawings. And that's mainly because Tekla sometimes does stuff like this, where it puts dimensions inside of each other that really should not be there. So even if your program is set up properly, do always have a run through your drawings and make sure they are doing what they are supposed to be doing. Good. Now that that is done, I'm going to take all of these drawings, I'm going to issue them, and that's so that if there is changes, I might change the model after drawings. Even though it's only a number change, it will tell me the issued drawing has been changed. Much harder to spot changes, drawings aren't issued. After that, I'm going to issue my drawings for, add a revision for approval. Here, let's add the date. Mark 01, and the reason for this is issued for approval. As this is the first step that goes out, it'll be for approval. Close this up. Once all that's done, we can quickly go and create ports, open that up over there. I'm going to select objects from my drawing list so that deselect that, so that I do not select anything like the stairs, not the stairs, the hand railing on me, as I don't want the hand railing within my order lists. So, assembly list I am going to create from selected, which should only be those 4. The assembly part list gives me again those 4, this time with a list of everything that's inside. As you can see, it does still give me B1 as existing, and that's because I've got its parts inside selected. But what it won't do is when doing a material list, it won't give me it again. Now, after the to assembly list, I'm going to do a bolt list complete. I'm going to make it from everything as I don't have any bolts selected, and I can see here all the right stuff is done there. From here, I'll go to drawing transmittal list, and I'm going to create from all, and this is simply a list of my drawings. As you can see, the names we used are shown up in here, as well as our revision and our issue and paper size. Close that. Material list we've already made. Let's just make it again. And the material list has each and every section size that are the same combined, giving us a total profile length and weight to make ordering easier. Part list is basically the same as material list, except everything is sorted into their individual marks. And that's it for the lists. Once these lists are made, I'm going to go and quickly export my model, create a TechLab BIM site, and I'm not going to open that. Like assemblies and bolts, I'm going to publish everything. Once this is created, it'll open up the folder with it. Sometimes it does take a while depending on the size of your building. And it'll open up this over here. Now, this TBP file can be opened up by anyone using the BIM site software, which is 3D download and use. Good way for a client to see what you've been up to and what the finished product looks like. After that's done, we of course would like to do some printing, so I'm going to select only my general arrangement drawing. I'm going to print that, just make this a little bit smaller, and I'm going to output this to a single file called GA drawing. I'd like it to fit to paper. Paper size, automatic, orientation should be landscape, but automatic should be fine. And I would like it to be black and white. And I don't want to preview and print. Now, once that's done, I'm going to select same for my main members. I'm going to call this assembly, print, and after that I'm going to do the same with my parts, giving 3 easy sets of drawings for my clients to use. Now, ideally, all my assemblies, all my GAs, and all my parts will each be the same drawing size. I usually set everything to be the same drawing size within a category, and that just makes it easier. I can just take one file, print everything out, and be done with it. And that should be everything. Hope you enjoyed it, hope you learned something, and I'll see you next time.